Welcome to lesson 3-7. That's topic 3, lesson 7. We'll be simplifying algebraic expressions today. Remember, expressions don't have equal signs. They're number sentences without equal signs. And algebraic just means it has a variable, a letter standing for some unknown quantity. And today, as we simplify, we'll be combining what are called like terms. Now, remembering back to the word terms, terms are part of an algebraic expression, and they are separated by addition and subtraction. So in this example right here, we have 3 terms, as shown by the highlighting that I did, separated by adding and then subtracting. Now, before we get into all the properties and how to mathematically rigorously prove all these things, we're going to look at it from a common sense point of view. So I have this equation 2a plus b plus 2b plus a plus b. That's quite an expression. It's got lots of parts. Actually, it has 1, 2, 3, 4, 5 terms. And if we can simplify this, make it look easier, simpler, then we want to do that. So let's pretend that instead of 2 groups of a, 2 times a is 2 groups of a, I have 2 groups of an apple, 2 apples. And instead of b, I have 1 banana, 1 group of a banana. And then the next term is 2b, or 2 groups of b, and we'll call that 2 bananas. And then 1a, or 1 group of a, an apple, and then 1 group of b, a banana. So if someone said to you, how much fruit do you have? How many apples and bananas? You wouldn't say, I have 2 apples, a banana, 2 bananas, an apple, and a banana. You would combine the like items, or the like terms in this case. And so let's do that. Move that apple over there, and this banana over here, and this banana over here. And now that I've combined them, I can say I have 3 apples and 4 bananas. And so what I've done is I've combined my like terms. Now let's look a little bit into what is a like term. So a like term is a term, a part of an algebraic expression, that is similar to another. So a constant, if you have constants in your expressions, they're always like term. Also, if they have the same variables, they are also like terms. And finally, if they are the same combination of variables, they are like terms. So here's an expression with 1, 2, 3, 4, 5 terms. And if I look at my list, first I'm going to look for those constants, and I have a constant term of 2 and a constant term of 1. I can combine those to get 3. I also can look and see if I have the same variable, and I have 2 different terms with a y in it. And 4 y's, take away 1 y, leaves me with 3 y's. And then, of course, I just have the 2x. That's not the same as y, so I can't combine it with y. So that's the simplified expression right there. Here's another expression. In this case, I don't have any constants. There's no numbers all by themselves as terms. Amongst those 1, 2, 3, 4 terms, I do have 2 with the variable r. So I can combine those. 4r plus 1r is r. And then I have a t, and then I have an rt. Those are not like terms because I don't have the same combination of variables. This one is just a t by itself, and this one is an r times a t. So I can't combine those, and so this is my simplified expression. Let's go to the properties and look at a rigorous mathematical proof of all this stuff. Okay, last time we learned about the commutative properties. We learned about the associative properties and the distributive properties, and those will be helpful in what we do. Now we're going to add one new property, and that's the identity property. And the identity property has to do with a number keeping its identity, not changing its value. And so for addition, we think, well, what can we do to a so that it doesn't change? Well, if we add 0, it doesn't change. When you add 0 to a number, it always stays the same. So the identity property of addition says we can add 0 and not change the value of a number. And then for multiplication, what do we do to keep identity? Well, we multiply by 1. 1 times anything is itself. So the identity property of multiplication says when you multiply by 1, the value stays the same. A times 1 is just a. 6 times 1 is 6. Okay. So Looking at this down here, x plus x plus x, and maybe you're already thinking, well, that's 3 groups of x, so that's 3x, and it is. Let's look at a different way of solving this. So I could use the identity property to say that 1 times x is the same as x plus 1 times x plus 1 times x. That's the identity property. Now I can use the distributive property to pull out a common factor to all those 3 terms. In this case, they all have a factor of x. And so it's going to be x times 1 plus 1 plus 1, reversing that distributive property. Now I can add the parentheses, and I get x times 1 plus 1 plus 1 is 3. Or, if I write it the sort of official way, just 3x, which is what you maybe knew intuitively. Let's try one more. In this case, we have a common factor of y, so I'm going to pull a y out, and 2 times y is 2y minus 1 times y is y. And now I can subtract, and I get 1 times y, or by the identity property, just y. And maybe you were thinking, if I have 2 bananas and I take away 1 banana, I'm left with 1 banana. And that's kind of a good way to look at it. All right, here's a little more drawn out approach to kind of labeling things as such. Again, 4z can become 4z. Minus z is minus 1z, because 1 times z is the same as z. Again, I can do 1z, 1 times z. And then here I have 2 times z, and I can pull out a factor of z. So using the distributive property, I've got my z out here, and I have 4 minus 1 plus 1 minus 2. And 4 minus 1 is 3, plus 1 is 4, minus 2 is 2 times z. So my expression that's simplified is 2z. Okay, let's look at this next problem. We have this hiking trail, and it goes in roughly a triangular route. And the flat section, that's labeled N. And then the other 2 sections of that triangle are labeled in relationship to the length of N. And I want to know the whole distance around in N meters. So the perimeter is the sum of the sides. So I have 2/3 N, that's that one, plus N, there's that one, plus 2n plus 4, and that would be that one. So we have this part, and this part. And I want to simplify that expression. So how many n's do I have? Well, I have 2/3 of an n, plus 1 more n, that's 1 and 2/3 n, plus another 2 n's, that's 3 and 2/3 n if I put those together. 3 and 2/3 n. Plus, so I've taken care of this and this and this. Now I just have this 4 here, plus 4. All right, this next section, we're going to add another section of trail. So this is my old section of trail from before. Now I'm going to add another section of trail that's represented by 1/2 n plus 1/2. And if I combine like terms, I have 1/2 n, and then I have really a 1n there. So that's 1 and 1/2 n plus 1/2. And I'm going to add that to the previous trail. Let's look at that. So here is the new and the old sections of trail. The new section I found out was 1.5 n plus 1/2. And the old section, that was 3 and 2/3 n plus 4. Let's put them together. Using the commutative property, I just rearranged my terms so my n's were close to each other and my constants were close to each other. The constant piece is pretty easy. 4 plus 1/2 is 4.5. The first 2 terms are a little more challenging to combine because I have halves and thirds. So I need a common denominator before I can put these together. And the common denominator is going to be 6. So I combine the 1/2 and the 4. those constants. Those are like terms. And now I've got common denominators with my n's, and those are like terms. So now I can add them up together, and I get 1 and 3/6 plus 1 and 4/6. 1 and 3/6 plus 3 and 4/6 is going to be 4 and 7/6 n plus 4 and 1/2. And 7/6, of course, is 1 and 1/6. So I actually get 5 and 1/6 n plus 4 and 1/2. And there is my simplified expression. All right, now we're going to be simplifying some more expressions. This time we have some parentheses and decimals, no big deal. So I'm looking at my expression 2 and 5/10 times the quantity 20 and 50/100 x plus 5 and 50/100 x minus 10. And so I can see right away that we have some like terms right here. So I can combine those, and 20 and 50/100 plus 5 and 50/100 is going to be 26x minus 10. And then the rest of it is the same. And now I can use the distributive property. 2 and 5/10 times 26x minus 2 and 5/10 times 10. That's the distributive property right there. And off to the side, I multiply 2 and 5/10 times 26, and I got 65x minus, and 2 and 5/10 times 10, I just move my decimal over one place, making it 10 times bigger, 25. And there is the simplified expression. And you can see why we call it simplifying. Look how complicated this is and how simple that is. Okay, this next one is for you to try. We have the same expression except for instead of making it 2 and 5/10 times bigger, it's 3 and 5/10 times bigger. So let me write the original expression for you. See if you can combine like terms in the parentheses and then use the distributive property and simplify that. All right, have at it. We'll talk about it in class. All right, we've got some straight up practice here. We're going to simplify these expressions, combining like terms. Look at the terms. If they have the same variable, then you can combine them. If they have this, if they're just constants in the term, you can combine them. So go ahead and give it a shot, and I'll see you next time.